Hi, I'm John Tomset, and as the Environmental Manager at Cirtex, I'm very proud to introduce our standard PortaFloc unit, which is a smart adaptation on the original GDO5 TB90 Floc Shed system. One of the great benefits initially, you can see with the PortaFloc, it's light, it's easy to handle. One or two guys can get this in sight, back of ute or so forth, right up to your area it needs to be installed. So you don't need the additional lifting gear and so forth that you'd need with the traditional TP90 Floc Sheds. As you can see, the unit comes on a pallet to site. Now this brings a couple of benefits. It helps keep the unit up and out of the mud and so forth. Now when you're setting these up, you need to be considering setting them up in a location where your dose point is typically around 5 meters back from the entrance to your sediment pond or decant. You want to be putting them in preferably on a nice level flat pad, out of the way of your machinery operation and so forth, also somewhere where you can get to it. Okay, so when we're looking at the sizing for your header tank, trays, etc., and they're detailed in your CTMP. So if Cirtex has done your CTMP for you, then we will specifically refer to the tray sizes, the positioning, and the header tank holes based on the header tank size. If your CTMP has been completed by another erosion and sediment control specialist, we will assist just with that conversion for you. All the details are also available on our hub, so whether it's a Floc Shed or a PortaFloc unit, there's a very useful calculator as well on the Cirtex hub. You can punch in there your catchment size, your dose rate, and that will detail all the header tank holes and sizings for you. So I want to go a little bit into detail now and show you through that header tank and some of the unique features and benefits of the PortaFloc. Okay, so we've removed the additional extension reduction tray. Now, when you get this on site, we want to take this lid off because inside the unit itself, we have your dosing hose, which you're going to require for the final components of the setup. We'll take this opportunity as well to show you the internal displacement tank. So obviously when the unit's full, this will rise accordingly. We're not going to bring it right out because it's secured through the easy drain system, which we're going to detail later on in this video. So when we go into the header tank itself, we've actually come up with this great innovation in the middle here. So your low and high flow holes will now go into this tube, which is located, screwed into the middle of the header tank. So you'll have your 3mm hole and your low flow and your high flow 10mm hole located as per the detail in that CTMP. Now just remember, the reason we have these low and high flow holes is to allow for the first 12mm of rain to accumulate before we actually start dosing. So that's based on the concept that ground's dry, we get a light shower, we don't get overland flow typically until we've had that 12mm of rain. So we don't want to be dosing pre that 12mm kick in. Okay, so one of the other great things about this tube is that as we go from site to site or we're changing catchment sizes, we need to also change the height on these holes. And so we're going to end up filling a few of these over time with silicone and drilling new holes, but ultimately once you do have a whole series of holes in this, you haven't damaged the integrity of your header tank itself. This is just a simple replacement part if required. Okay, so we've run through the header tank detail. Let's assume the holes have been drilled at the correct sizings. So the standard catchment tray is 0.5 square meters on this unit. Now everything is correlated to take this to a maximum catchment of 1.5 square meters. So firstly, we have this extension reduction tray here, again, another 0.5 square meters. And we can supply a second tray as well with this unit. So you can take this unit out to 1.5 square meters before you need to consider going up to the large PortaFloc unit. So this tray here, as you can see, has these holes. So if we want to increase our catchment above the 0.5 square meter, this tray is going to come out to here. This now allows the ability for both the water that's landed on here and this additional 0.5 square meters to make its way down and through the displacement system. Likewise, if we want to reduce our catchment, say for example we have a catchment of 0.4 square meters, we'll reverse this. Now the water that's going through the displacement system is just the water that's entering on this area or landing on this area, and any water that lands on this tray here is just going to pass off and out of the back of the system. Okay, so we're going to look at a little bit of the detail on the securing the tray itself. We've actually devised an aluminium C-track section here. One of the benefits of this is it's easy to change the sizing of the tray as your catchment sizes reduce or enlarge. but it also gives us the ability to create some elevation here as well. So in this instance, we want to be shedding water away from the tray. So we can just simply just by changing the angle on these, we can create that elevation just to avoid the accumulation of water on this top tray. So, and then these can just be tightened and secured accordingly. So if we look at that in reverse as well, then these back ones can then be elevated. So if we're now bringing water onto the tray, again, we can create that elevation that's required to ensure that that water's passing on to the secondary catchment tray. So when this secondary catchment tray is coming out to these sort of distances, you want to be supporting them with an additional Waratah or two. That can be screwed in and secured like so there. Again, think about the elevation of the tray, whether it's shedding the water or being elevated to accumulate water. And that will give it all the security it requires in a high wind area. Okay, so now we've sized our header tank and catchment tray. So the next part of the equation is to get that dose point all lined up. So as we talked about earlier, this is in the PortaFloc unit itself. So this pushes on to the outlet. And we have this nice screw system as well. Now it's really important when we're doing this to ensure that we have downhill gradient all the way along here. We don't want to see this, otherwise we're going to have an issue with displacement where the level's got to rise. So let's assume here that the dose point for this particular install is here. We'll cut the pipe here, either using a pipe cutter or similar. Safety caps on. Now we're setting this dose point up at about 150 off the ground level, off the floor of your entrance channel here. We don't want it too high. Again, in a high wind environment, big storm environment, flocculent, we don't want it blowing around and potentially missing the dose point. But also 150 above the ground ensures if we do get a sediment accumulation during a rain event that this pipe itself doesn't get buried in accumulated sediment. Again, we've got this nice uniform gradient coming down here, just ensuring there's no backup of flocculent in the dose hose. Now before you proceed with filling, one very important part, make sure this is closed. This is the displacement tank drain from the inside which we talked about. We want to make sure that this is closed, otherwise when you get rainfall accumulation, water's going to land in the top displacement tank and pass straight out the system, ultimately not activating the displacement system itself. Okay, so we now have our trays set up, catchment tray set up, and our header tank holes as per our CTMP. We have our dosing hose in situ, so ready to dose in the centre of our entrance channel to the forebay or to the decanting earth bund. Now to fill the unit, we do it via this 18mm garden hose fitting. So there's a hose running internally in here, down into the chemical reservoir, which sits obviously on the outside of the displacement tank. So if you're filling from a 200 litre drum, we recommend you use our easy pump system with the 18mm hose connected and the female garden hose attachment. Now this unit will basically take 200 litres to fill. Alternatively, if you're using a 1000 litre IBC, you can elevate that IBC on a secondary empty one or full one, whatever it might be, or on a stockpile, and then this unit can be gravity fed. Again, that IBC connection hose has an 18mm female fitting, and then this can simply be gravity fed. Okay, so the unit's been up and running on site now for a couple of weeks. We've had a number of rain events. We approached the unit. We've obviously been doing our maintenance checks, our reporting requirements for council. But we noticed that we've lost about 40-50 litres of chemical. We do have 130 litres of rainfall capacity here before the unit will stop displacing. However, very good practice to recharge the unit when we're in the green zone and not get ourselves into the yellow before we're thinking about recharging the unit. So when we look at the header tank itself, when we want to drain that back, we can either remove that central tube and allow the water to go through into the displacement tank. Important to remember though, however, if we do that, we open this bottom tap first. Otherwise, we're going to be displacing additional flocculent. So let that water go. We might want to connect up an additional section of hose from our IBC filling hose or similar. Now that's going to take a couple of minutes for that water to drain away. So now's a good time to go and do our pond checks. So when we return to the unit, all this water's now gone. We close this tap again and repeat that filling process I detailed earlier in the video. So one of the great features I love about the PortaFloc is the ability to see the level of the chemical in the unit at all times throughout the range. So again, when it's filled, that is identified through the base of the displacement tank being black. So we can very clearly see when the unit is full, and we can very clearly see through the tank wall itself the level of chemical and accumulated water as it drops through the range. So if we look at the detail of the bottom of the PortaFloc unit, we have these anchor points here. The unit itself is secured with heavy duty cable ties to the pallet. This pallet ensures that the unit is up out of the dirt, out of debris or away from sharp stones or similar. It also gives some protection here around the drain for the displacement tank, and it helps ensure as well that you're getting this set on a nice level platform. So just a few things I'd like to note as we close out. It's absolutely imperative to remember that the PortaFloc system absolutely emulates the principles of the TP90 GD05 Floc Shed. That's a rainfall displacement system with a header tank that allows for the accumulation of 12 ml of rain pre-dosing. So, also just like to reiterate that Cirtex does that whole service for you. So we can provide your CTMP for site, all the chemicals required to get up and running, and training of your team as well. Flocculation for a lot of the guys is a new concept. It's really important to understand what we're doing, why we're doing it, the nuances of chemical treatment, flocculation, and somewhere to come if you do get problems on site.